Well, good morning and welcome to the GlobalFoundries webinar on leadership positions supporting analog, power, and RF. So let's get going. So up with me here, I'm Paul McLellan from Semiwiki.com, by the way. And then up with me here is Aabid Hussain, who's the Vice President of Business Development and Modeling for Analog Power and Mixed Signal Technologies, which must be about the longest job title in the world. And in this role, not surprisingly, he's responsible for building the analog business for GlobalFoundries in Singapore. Prior to joining Global, he was at Dongbu High-Tech and was instrumental in building their analog and power business for over 10 years. And then over on further to my right, your left, is Paul Colestock, who's the Director of Segment Marketing. Prior to him joining Global, he held leadership positions driving innovation in product design, methodology, and manufacturing, both in startups and in bigger players such as Hussain Labs, Jazz Semiconductor, Agilent, and here, Cadence Design Systems. So, since we're going to talk about analog, I think probably one of the first questions is, well, what is analog? Because it's something that means different things to different people. So what is it we're talking about here?
First of all, thank you very much, Paul, for having us here today. So let's define what an analog means here. At the highest level, anything that is non-digital, anything that is outside the realm of digital or memory product can be considered as analog. So products that are serving a lot of functions in analog domain or serving high voltage power kind of products, products with a lot of RF kind of content, or sometimes even MEMS products can be all put together into an analog category. Analog market is a very important market, right? It has been there for many, many years. And we as a human are analog. Anything that we interact with electronic product is through an analog means. Speech, touch are all analog interactions with the electronic products. Moreover, the signals that come out of electronic device and that we consume, like music, display, is in an analog domain. So no matter what happens in an electronic device, it has to interact in an analog fashion. And so that's why the analog market is always a very important market that companies like us has to serve.
How big of a market is it?
Yeah, well, I know, but why don't I address that? Before I do that, one thing I want to say about why analog is important to us is it actually allows GlobalFoundries a unique opportunity to level the playing field from a foundry point of view and to help customers that want to compete with IDMs that actually have their own 300 millimeter facilities that they're manufacturing analog components today in. So that means that they can take advantage of the same things that these IDMs can take advantage of, which is more die per wafer, so it's better cost advantages, and also the back end. So bump, for example, there are advantages on being on 300 millimeter. So not only from, as what Aabid was saying about, just the general why analog is important, and I'll talk about the markets. There is this theme around 300 millimeter analog, which is unique for foundries and which we're going to drive, and we'll talk more about that when we talk about the platforms. In terms of the market, analog is very diverse, right? From data comparators, amplifiers, and power management, et cetera, and also, more kind of application-centric analog that goes into all the markets, whether it's power management chips in the mobile, et cetera. But it's a big and very diverse market. So outside of kind of RF and MEMS, as Aabid has defined it, it's about a $40 billion in semiconductor market today, growing at a healthy rate, growing some cases double the actual semiconductor regular semiconductor revenue. Sometimes even up to 20% growth, depending on whether it's power over Ethernet, et cetera. If we add in that growth, it's about a $60 billion market by the time we get to around the 2016, 2017 timeframe. If we want to add in the RF piece, RFICs, for example, that's another $20 billion semiconductor market. If we want to add in kind of the RF front-end module components, or RF components, that's about another $10 billion market in 2017. That market today is served mostly by compound semiconductors, but there's a transformation happening there where people are designing a lot of these now in silicon. And while it's a small percent of the market today, it will grow at a very healthy rate over the next few years. MEMS, as Aabid mentioned, is another part of how we classify what we're doing in analog. And today, from a foundry perspective, the end market's about $5 billion, but it's also growing at about a 10% clip. So from a market point of view, it's a very healthy market, it's a very growing market, and it impacts every segment that we want to go after as GlobalFoundries.
So it's growing fast, so that makes it, on its own, makes it an attractive market. Are there other aspects of analog that make it especially attractive for a foundry?
Well, part of it, I think, is the innovation piece. And if you look at, I think I want to take some time to define how we at GlobalFoundries look at what we call leading edge. And I know if you think in the industry, most of leading edge is defined by digital. And so always leading edge today would be, people are doing, we've announced 14 nanometer, 10 nanometer we might consider bleeding edge. But for us, we define leading edge relative to the actual applications and segments where they find themselves. And we do this because we do believe that innovation does occur at the leading edge. However, we define leading edge relative to products. So for example, yes, for digital, it's all deep submicron and 14 nanometer. If we're talking about automotive, for example, that's going to be around the 40 nanometer. For the MCUs, about 40 nanometer, around 180 nanometer, right, for the power semiconductors, et cetera. So for us, leading edge is relative to the products that are being developed, which allows us to focus on where the innovation is going to happen. And I should say for analog especially, this is high innovation per transistor. This is not deep submicron where the innovation per transistor is extremely low. This is innovation per transistor that's very high. So the devices are very, very important in making the end product not only differentiating, but also profitable. So a lot of innovation can happen in analog because there's still a lot to do with the device technology. We see customers innovating across the board. And as we'll talk about later in the platform technology and platform approach we take, that's there to help us capture all this innovation as we're defining kind of what is the leading edge for these different product segments.
Yeah, I may want to add to that a little bit. From our perspective, it is very, very attractive because, as Paul said, innovation. So we're innovating into the silicon and on top of silicon. And that makes it very attractive for us also and for our customers. Our customers who are major in mobile market, automotive market, or industrial market can use this innovation that we can bring to the market for developing very innovative products for their own end applications.
So what processes are we really sort of talking about here, and how are you putting those together inside GlobalFoundries?
So we already have a very good platform today in this analog power domain. We call it a BCD Lite platform. We have it at 180 nanometer. That has allowed our customers to come up with very innovative products in all the segments that we have just defined, mobile, automotive, and industrial segments. We are working on a 130 nanometer platform. We have rolled out a couple of modules of that platform. And we are working on another platform, which is a 65, 55 nanometer, and maybe we'll go to 40 nanometer platform also.
So which are the markets that you guys are most focused on that are sort of driving all of this growth right now? When you talk about RF, it's probably not too hard to guess as to what market's driving that, but some of the other analog is less obvious.
Yep. Well, I think actually the nice thing about analog is that it's we call kind of a horizontal technology. So our key platforms for GlobalFoundries are mobility, which pretty much everybody believes mobility is a big market. It is. We define that as kind of the mobile PC, the tablets and the handsets. Analog has a big role to play, but not only in kind of the discrete components, but also driving the power management. Imagine today you've got multi-core application processors and multi-core baseband processors that all are driving this transformation in terms of power management. I think some of these, even if I'm not mistaken, can draw as much as 9 amps of current. And it has to be managed at the granularity of a multi-core apps processor. And so that's driving from the mobile platform is driving innovation on power management. Also in automotive, which is another segment we focus on. You look at all the things that are happening in the car today, all the things around driver safety and infotainment, and electric vehicle start and stop technology. The analog content there is quite high. If you think about how many microcontrollers you find in automotive, in a car today, there's as many as 120 different microcontrollers. Around every one of these microcontrollers is probably 18 different power semiconductors. So the combination of the MCU and the power, the market trends are driving a lot of innovation in automotive. The same in industrial, where they share a lot of the same infrastructure to build the kind of products, and also things that are happening in the server space. So we have a segment which we focus on, which is compute, connect, and store, which is everything around the data center. So for the new server technologies, it's the network processors and switch technologies, as well as the infrastructure and the access to the infrastructure. Again, all of these are now focused on not just high performance, but also power. Components have to drive the actual power management aspect of that. So that's a big theme for us as well.
There's really a big difference now between the voltage level at which we're running these big SoCs and the kind of things you're talking about here in cars or airplanes or anything like that.
Big disparity, but I would say that don't rule out that you might see combinations of these semiconductors and or new process technologies that will push in a modular fashion, as we'll talk about more in our modular platforms, push some of the higher voltage technologies into what would be considered more SoC type processes, right? So this kind of idea that we're building platforms around, which is the multi-technology platforms. It's really important because as platforms roll forward, especially if we want to address kind of this, the connected everything and the Internet of Things, this has to be ready with a microcontroller. It's got to have sensor interfaces, high voltage interfaces, non-volatile memory for personalization, maybe even MEMS technologies. And that's, again, it's building this multi-technology platform. That's why we're so focused on analog. Analog here, as we've discussed, being just the analog pieces, the high voltage pieces, the RF pieces, as well as things like MEMS and non-volatile memory.
So tell me a bit more about these modular platforms. This is the way you actually build up these things in the fab.
Yeah, so let's define a platform here again first. A platform, in our case, what we mean is a base technology. We can take a 0.18 micron or a 0.13 micron base process, can be a good digital or a mixed signal process, and then you build different modules on top of this platform, on top of this base process, to give you a very nice platform such that the customers can use this platform to reuse their IPs that they can develop and create different products out of it. And they can innovate on the platform. We innovate in the platform, and the customers can come with their own ideas, own devices, own IPs to innovate into the platform.
So they can kind of mix and match various technologies. Is that how it works?
Yeah, so they can take different components. For example, they can take high voltage devices, could be up to 30 volt, could be up to 60 volt, or maybe even up to 700 volt. Using the base process could be just a 1.8 volt, 5 volt in case of 0.18 micron technology, where the IP is reused, but they can develop different products with different voltage levels.
So imagine today they start with the base technology that may be our BCD Lite technology, but then they find that from the application that they're serving, they need to take that product one step further. They've already have this big investment in the design infrastructure and the IP that they built. How would they take and evolve the product? In some foundries, they may have to move to a different process technology. They may choose and think about maybe let's go off and build something kind of unique for us. But the real value for them is that they've done the investment on the design infrastructure. They've done the investments in the IP itself. They can evolve their own products in a natural way as the market evolves. And that's, again, back to why we have segment marketing at a foundry, is that having segment marketing and application-focused people like us allows us to kind of understand where that market's headed, from a chipset solution point of view or a segment point of view, and make sure that those solutions are ready and available as options in these modular platforms to make sure that when our customers are ready to take advantage of those, that they'll be there. And remember, not all customers come at the same time, right? They come from different backgrounds, they've got different product histories, and so they intersect us as a foundry and a platform at different times. And having this kind of platform approach which Aabid has helped driving within the company, helps make sure, based on our market knowledge and input, that we can have what we need and available for customers when they need it.
So is this a higher level of integration actually on the silicon for analog compared to doing more integration at the PCB level?
Yeah, so there's definitely a high level of integration both in the silicon and on top of the silicon. So for example, you can take a PMIC or a PMU that are heavily used right now in mobile applications, cell phones, smartphones, and tablets. That can have as many as 8 to 9 LDOs, maybe 10 to 12 different voltage regulators, And then they can bring in different components, passive components that usually were hanging out outside the chip on the PCB into the silicon. So they can do resistors, capacitors into the silicon. And now people are trying to put things, passive components on top of the silicon using different kinds of techniques, even MEMS techniques on top of the silicon. So the integration has become extremely important to make this kind of product realize.
Sort of SoC of analog.
Well, you know, I mean, this is the multi-technology platform is we're defining it. It's there. I mean, people want to use it, but it's not limited to just silicon. You know, once you get into this realm of, 300 millimeter, for example, all of the things that 300 millimeter has in terms of development, whether it's this 3D packaging, so TSVs and micro bumps and other enabling technologies that allow you to have more 3D integration as well, can be made available. So depending on the product, not all products need to take advantage of this, and depending on the architecture, and we're also working on these kind of advanced packaging technologies as well, it allows the customer to build the right kind of product based on the application that they have, whether that's all integrated in silicon, some integrated on this board as well as silicon, and maybe even, for the future, some integrated, in more of a 3D stack fashion.
So these markets you're basically addressing out of your Singapore fabs, is that right?
Yes. So we are currently addressing these markets out of our Singapore fab. In our Singapore site, we have a very nice combination of 200 millimeter and 300 millimeter. We're expanding our 300 millimeter capacity to serve this kind of markets. But the customers can have a very nice feature set, both in 200 millimeter and 300 millimeter, and take their products as they ramp up from 200 to 300 millimeter to realize the cost structure that they may be looking for.
And you're expanding your capacity there in Singapore for this now?
Yeah, so we have been very committed to Singapore manufacturing site. Our company has made a strategic investment of about half a billion dollars into expanding the capacity both on a 200 and 300 millimeter. We are on a trajectory of getting up to 1 million wafers a month on a 300 millimeter footprint.
And that's all analog, or are you running some digital stuff in there as well?
Right. On the new capacity, it's to be a mixture.
Yeah.
I mean, we have the platform.
Sounds like, I know, yeah.
Well, the platforms we support there, we have 130 nanometer. We'll have 180, which is something new we're bringing as we're building out the 300 millimeter footprint for analog. But we already have the 65, 55 node as well as 40 nanometers. So pretty much Singapore covers large geometries down to 40 nanometer.
Right.
But back on the point that Aabid was making, about having both 200 and 300 millimeter footprints and manufacturing available at one platform. So it allows, if you're in 0.18, let's say our BCD light platform, you have products that can take advantage of the economies of scale that 300 millimeter will bring you. That same design can be run basically in 200 or 300 millimeter. It really depends on the product, the kind of architecture, and how the market perceives your product, and if you can take advantage of things like larger die, for example, so you get the cost benefit of being on 300 from a die point of view, or the bumping, for example. So if you're heavily dependent on bumping, how much more does it really cost you to bump a 300 millimeter wafer than it does a 200 millimeter wafer? So there's other kind of economies of scale that you get. And I should say, as I mentioned before, there are IDMs out there today that are doing analog products in 300 millimeters. So from a competitive point of view, having that cross-platform or cross 200 and 300 millimeter platforms allows us to get customers to be more competitive in the marketplace.
So in some of these markets, like automotive, it seems to me that one of the big drivers there is just the huge increase in the electronic content and foreseeable going through into the future as well. Drive-by-wire, self-driving cars. It all seems like some of these things are sort of maybe a little bit further out than a couple of years, but sort of wonderful, likely to drive the market for a long time.
The automotive market has come a long ways, right? Both under the hood and inside the cabin, the electronic content has steadily grown. And with that, the analog content in the silicon has become very, very important to realize a lot of the functionalities that happens both under the hood and in the cabin. Paul and his team has been working very, very closely with the automotive market. So Paul, you may have a little more to say on that.
Yeah, I mean, as I discussed before, there's a wealth of opportunity for analog. And also things we're doing in 300 millimeter around embedded microcontrollers. As I said, about 120 of these today, growing as we speak. A car is actually a mobile platform. It's actually a mobile device with a car wrapped around it. If you sat in a Tesla or some of the other cars today, if you go to CES or even Mobile World Congress, you can see just how much of a mobile platform it is, and that's driving all this connectivity. It's driving all the sensor technology. I mean, the new interfaces that they have for driver safety involve multiple cameras in the car watching what the driver is doing actually facial recognition and following your eyes, tracking if you're being attentive on the road. All the forward-looking sensors like the automotive radar and the vision sensors, looking for obstacles that are in your way to help you stay more focused on making sure that you're being safe. And you put all that together and all the interfaces you need to interface with all the microcontrollers and all the buses. It's a good wealth of analog. But to your point on the longevity, automotive is one of the longest serving markets that you have as a foundry. They come in a little bit later than most products do to your foundry technology. Most of that is they require very high reliability and standards that they have in terms of zero tolerance for defects, et cetera, means that once they get started, however, these systems can live in cars for quite a long time. And while I would say that they're going to more kind of innovative solutions, it's maybe shortening the time that it takes for upgrades in automobiles. It's still a market that is good for foundry, good for analog, and good for GlobalFoundries.
So maybe we'll sort of wrap up here and then move on to the Q&A. So do you have a few sort of final comments on the market and GlobalFoundries business and the modular platforms, and what just sort of summarize?
Sure. Yeah. So first of all, I would reiterate that GlobalFoundries is very, very committed to serving in the analog power mixed signal RF market. They have been making a significant amount of investments, and Singapore site is going to be a very important site to manufacture our customers' products in this analog power mixed signal and RF domain. With the 200 and 300 millimeter wafer form factor available for doing the products, it becomes extremely cost effective and economies of scale available to customers to make this thing very, very cost effective for their end applications.
Yeah, and I'll just reiterate what Aabid was saying. Singapore, a very important site strategically. It's part of our global manufacturing base, the diversity and the geolocality of where we're manufacturing. But also, as I was saying before, I just want to make sure and reinforce this concept of where innovation happens. And again, this idea of what is leading edge, right? So for us, leading edge, yes, we do it at the bleeding and leading edge with our digital products and customers. But also, we're very, very keen on innovating in Singapore around things that come around the analog and RF and power management, because these products have their own definition of leading edge. And that's where innovation is going to happen. That's where we're going to innovate with our customers in a very collaborative way. And Singapore plays a very important role there for us as a company.
So we'll move on to questions. So once again, if you want to ask a question, then click on the little chat icon and type your question, and it will come through to here. And then a mysterious disembodied voice will read it out.
Well, we did receive some questions. So let me start with the first question. Does GlobalFoundries plan to offer BCD technology?
Let me take that. Thank you, Jeff. Yes, GlobalFoundries today is offering a platform called BCD Lite. Essentially, it is a BCD process with a non-EPI and a non-NBL offering. Going forward, GlobalFoundries is developing what we call internally as a true BCD process that will be available for higher voltages and for applications that Paul was describing for automotive and industrial markets.
Thank you.
A great question.
Might be a good idea just to explain what BCD is, because I'm not sure everybody knows.
So,
or at least what it stands for.
Thank you, Paul. Yeah.
Thanks, Paul.
So BCD stands for bipolar CMOS DMOS process. It's a industry known terminology where you can do bipolar devices, power devices, and a CMOS all into one silicon.
Right.
Thank you. We have another question. What role do modular platforms play in innovation?
Yep, why don't I take that one off?
Sure, please.
So I think, as I was saying before, it's very important that we understand where innovation happens. as we're defining it, as we define leading edge, it happens, where companies are innovating. Analog, being high innovation per transistor means that there is a lot of innovation going on. But what can happen is that as companies want to innovate and they work with foundries, they could go off and develop all these kind of one-off technologies and innovate on their own and innovate kind of in parallel with all of their colleagues. What's good about the platforms is it allows us to capture all that innovation in a comprehensive way that not only brings value to them in terms of IP reuse, design reuse, et cetera, but also for us in terms of the efficiency of supporting a lot of these new technologies that we are bringing to market. That's very key. That's a great question.
Great. We have another question, a third question. What makes GlobalFoundries different than the competitors in the analog area?
So there are many aspects to that. GlobalFoundries, first of all, is committed to this thing in a very large manner. So both at 200 and 300 millimeter, by offering that to customers, we differentiate ourselves with our competition very significantly. In the foundry industry today, probably we are the first one or the leading foundry to offer the same platform, especially in analog and BCD market, on 200 and 300 millimeter wafers.
Okay, thank you. And I think we got one more question. What type of IP will GlobalFoundries provide to the customers that makes a foundry competitive in the analog market?
Well, you want to take that?
Sure. So, today we offer IP, and we're planning to offer IP around the automotive segment. So things like data converters, et cetera, that can help, customers do more designs for the automotive processes. This is really a manifestation of how IDMs have started to outsource a lot more of their automotive business, especially around microcontrollers, et cetera. They're not building fabs anymore. In fact, none of them will ever design another product in their own fabs around the microcontroller. So we are putting in place, and not all quite there yet, but we are putting in place the key IP for automotive, and are looking at, on these other platforms, building out a substantial amount of IP, analog IP, to help customers innovate going forward. And especially on these kind of multi-technology platforms, we already offer, with all of our partners in the industry, the embedded MCU technologies and IP that's required.
So if I can, let me add, we're offering both kinds of IP. I call it a soft IP that comes with a design IP like data converters, NVM. But we are also offering a lot of hard IP, which is in the silicon. So we are designing different kinds of resistors, capacitors. We are innovating different kinds of power devices and offering some kind of means to do IP development on top of the wafer, like spiral inductors and other such passive devices that can be done. These are all IP that customers can use on our platform.
Great. We have another question coming in. When does it make sense to switch from 200 millimeter to 300 millimeter? Kind of the comment that goes with it is, in reference to a particular feature or size or chip area dedicated to power, RF, et cetera.
Yeah, I think if you should take these on a case-by-case basis, but a general rule is that if you look at the size of the components you're building, it needs to be large enough that if you take the number of die and the cost savings on a 300 millimeter wafer and aggregate that across, distribute that across the number of dies you get, it needs to be something substantial. If it ends up being fractions of a few percent per die because you've got 10,000 or 20,000 or 30,000 die on a wafer, it doesn't really make sense. So it needs to be, from a chip area point of view, it needs to be large enough that the cost savings in terms of the number of die you get versus the cost of a 300 millimeter wafer is appreciable. So I would say 5 to 10% gives you a little bit of margin improvement. The other one I would say is that if bump is very important to you, and a lot of analog products are bump now, there is an additional cost savings in moving to a 300 millimeter platform because the differential in bumping on 300 millimeter is not it's not as much as it doesn't scale with
less than twice as much.
It's
the same area, or twice the area.
So I would welcome anyone who's thinking about how these platforms make sense for them. Contact us at GlobalFoundries, and we can kind of walk you through that thinking.
Yeah.
And help you with your product planning as you look at whether it's a 200 millimeter product you want to develop or a 300 millimeter.
Well, I think we'll wrap that up. Thank you all for attending, if you're attending live, or for watching this, if you're watching it after we've recorded it and put it up on the website. And I'd like to thank two esteemed people from GlobalFoundries who are experts on all of this, Paul and Aabid. And
thank you very much.
Yes, thank you very much.